Welcome once again to the discussion of what do you need to know about differential equations before you get to the Calculus BC AP test. As we've talked about, some differential equations is a vast topic, and you'll probably take this class sometime. The AP people ask very select few things about differential equations, and these are the four listed here, and today's specific one is Euler's method. Once again, not Euler's, Euler's. So let's talk about Euler's method. It is asked almost invariably every single year, whether it's part of an open response question or a multiple choice, but most likely it will be one part of one multiple choice question. But it's not too bad, and it'll be points that you can get if you're ready for it. So here's the setup. First of all, you will not see a picture like this when it comes to it. In just a minute, we're going to look at an example from an old AP exam. But for now, so I can explain to you what's behind the scenes, we're going to look at a picture. You're going to be given a differential equation. This black graph is one specific solution to the differential equation that happens to pass through the point 1, -2. Okay, there are infinitely many ones that all go through different points, but when you solve a differential equation, they're giving you basically the slope at any point. You know, all these little blue lines indicate what the slope is at that point, and you have to find the one specific equation. For example, if this was the starting point, if this were the starting point, our equation would kind of go like this. It has to follow along with the slope at every point. So at every point, my line should be pretty much parallel to the blue lines, and it did okay. You know, if we had a point down here, it would be steep and then leveling out some and getting, it's kind of hard to draw those. But anyway, we are focusing on the one solution that we have the graph for. Now, remember, you're not going to see this on your Euler's method question. Euler's method is an attempt to estimate where this graph will end up as you go from 1 to 2. All right, we get the starting point. Our goal is to figure out what's the height of this dot. You know, the y value of this is the goal. You're going to end up, and the answer to an Euler's method question is a number that is the y value of some spot along this solution that, remember, we don't have. I know that it's hard to picture this because you do see it, but just keep in mind you won't see it. So Euler's method basically does this. What do I know? I know a point, and since I'm given a differential equation, I can also find the slope. So the things I know right now is where I am and what my slope is. Basically, I know the slope of the little blue dash right where I am. With slope and point, you can find out a tangent line. So technically what you're doing is taking this point and the slope and forming a tangent line that is tangent to your graph at the point in question. So we're going to get basically the equation of this tangent line that touches our point and is tangent to the curve. That's all I can come up with because all I know is the slope at this point and that point itself. What you do in Euler's method is you follow that tangent along for, let's say this is going to be a 2-step. In your book, sometimes they'll have you do 6, 8, 10 steps. On the AP exam, I've never really seen more than 2 or 3 steps, so we're going to do 2. So what you do is you step half of the way down the line from 1 to 2. So we're going to go to 1.5. And at 1.5, we're going to basically recalibrate like your GPS does. You know, when you turn away, your GPS doesn't want you to, it's like recalculating. At this point, because I know the equation of this line, which is just a y equals mx plus b line, I can find this point using that equation. Right? So I would plug 1.5 into the equation of this line, and now I have that equation. And basically, I know the coordinates of this point. Let's call this x1, comma y1. We'll call this x0, comma y0, my starting point. x1, y1 I know, and since I have a point, I can plug that point into the differential equation to get my new slope. as you recalibrate, you're getting back to the blue dashed slope. And what you do is you just repeat the process. You get a new line that goes through this point that is parallel to the blue line at this point. So I'm right on a blue line, so I can kind of see my new straight line should go something like that. So as you move your 1/2 of a unit from starting point to middle, you started out on the perfect slope, but you got off track because the slope is changing and we're moving along a straight line. So the GPS goes off, it says recalculating, and we get a new slope. And then we follow that new line that we've made. And then since this is just a two-stepper, we're going to follow it to 2. So if our goal is the y value of that dot, this is our estimate. Euler's method is a way to estimate one value of one solution of a differential equation, okay? So I get that there's a lot behind the scenes. The good news for us is that we're going to break it down into a nice, easy way to solve this. So make sure you write this down, all of this. We're basically going to be taking steps and at each point calculating a new height. And the new height is going to be based on a tangent line of our previous point. So what it comes down to is your new y is equal to your old y plus your step size times your old slope. All right, so we've got it in words and in symbols. y1, the height of your, y1 is technically your second dot if you started at y0. The height of your second dot is equal to the height you were plus the slope times the step, basically. And that's just some good old-fashioned Algebra 1 linear stuff. If you want to know where you are going, you need to multiply the slope of the line times delta x, or the step. You know, if this thing is rising at, let's call it a slope of 3/4 or 3/5. Okay, if I rise at rise 3, run 5, and let's say delta x is 10, then I'm going to rise a total of 6, because for every 5 steps I take to the right, I go up 3. So that means from there to there is 6. That's all this is based on. And I maybe should leave that out to not overcomplicate it, but just realize your new y equals your old y plus your step size times your slope. That slope is going to come by plugging in x and or y to the differential equation. Okay, so differential equations are different than usual functions we work with, because usually we just plug in x and get y. You might have your slope might be based on both x and y. So after all that, make sure you have that written down, and let's go to an example. All right, this is straight off of the test from 3 years ago. Consider the differential equation. This one is only based on y, so we're only going to plug in y to find the slopes. Basically, we need to know the differential equation, which we have here. We need to know the starting point, which is here, and we need to know what they're asking us. They are asking us to figure out what's the value of f of 0 given the value of f of 1. So we're going to be stepping to the left twice because it says we have 2 steps, and we're just going to use this formula. New y equals old y plus step size times slope. We are starting at 1. If we're going to take 2 steps of equal size to get down to 0, then each one of those steps needs to be negative 1/2. Okay? So my y1 value, which is my new y, I'm working with this one right here, is going to equal my original y, and my height at 1 was 0, plus my step size, and this one actually brought up a technicality that if we're stepping to the left, that's a negative 1/2 step, times the slope evaluated at my original point. So my original point is given. It's f of 1 equals 0. And I'm using that to calculate my next point. So I need to find my slope, my dy dx, at the point 1, 0. And dy dx, which is right up here, is only 1 minus y.
So 1 minus y is 1 minus 0, or 1, which means that the slope of this line at this point is equal to 1. All right, so there's that 1 right there for f prime of x sub 0, y sub 0. F prime and dy dx mean the exact same thing. So what's this tell me about my new y value? If it's 0 plus negative half times 1, it's negative 1/2. Okay? I get that there's a lot going on here, but you'll catch on. Just follow the pattern. What's my next y? Now I'm here. I'm only taking 2 steps, so this is actually my last step. My next y value is where I was, negative 1/2, plus my step size, which is always negative 1/2 in this case, times my slope at x1, y1. x1, y1 is negative 1/2, negative 1/2. All right, because I know my x is negative 1/2 because I started at 0 and took a step. Oh, excuse me. I started at 1 and took a step to the left, so now I'm at positive 1/2. Positive 1/2, and then there's my y1, my negative 1/2. So I need to find the slope there. So if I take that point and I do 1 minus, this is the y, that's the only thing that this depends on. I'm going to do 1 minus y and get my new value of the slope to be 1 minus negative 1/2, or 3/2. So that's the slope at my midpoint. So I'm following that tangent line along for my second step that has a slope of 3/2, and it turns out that my next height is negative 1/2 plus negative 3/4. Right, I multiply those two fractions, and negative 1/2 plus negative 3/4 is negative 2/4 plus negative 3/4, which is negative 5/4. Okay, so this topic, possibly not the best to be discussed via video, but as long as you get the steps down, we'll do some practice in class, and through more repetition, it'll start to work out. And once again, you're going to see it on your test, almost guaranteed. All right, so there we go. That is Euler's method, the last new thing I'm going to show you before your exam, I think. This is Broseph Wibbles. I'm out.